Java build tools are the tools that help us to package our application into a distributable format, and they automate the entire process of building the Java application. There are several build tools available for Java. Here are some of the most popular ones. The first is Ant or Apache Ant, the short for another neat tool. The original name of the project when it was created by James Duncan Davidson in 2000. Ant is a Java based build tool that is used for automating the software build process. It's an open source tool that was originally developed by the Apache Software Foundation and is still actively maintained and supported, and provides a flexible and extensible framework for building and deploying software projects with a focus on simplicity and ease of use. It allows developers to define build scripts that specify how their software should be compiled, tested, packaged, and deployed. So, some of the key features of Ant include a simple and flexible XML based build file format, built in support for compiling Java code, running unit tests, and creating jar files, a wide range of third party plugins and extensions that can be used to extend its functionality, integration with other build and deployment tools like Maven and Jenkins. And Ant is an older build automation tool. It is here for many years, but it is still widely used, especially for the legacy systems and for the simple to medium kind of projects. It is often used in combination with other tools in the software development pipeline, like with version control systems, continuous integration servers, and deployment automation tools. Another very popular build tool is Apache Maven. Apache Maven build tool focuses on convention over configuration. And the primary goal is to allow a developer to comprehend the complete state of a development effort in the shortest period of time. To attain this goal, Maven attempts to deal with several areas of concern. That is, making the build process easy, providing a uniform build system, providing quality project information, providing guidelines for best practices, development, and allowing transparent migration to new features. Apache Maven is a popular build automation tool that uses again XML files to describe the project dependencies, build goals, and plugins. Maven uses a central repository for downloading the project dependencies, which makes it easy to manage complex projects with multiple dependencies. So, the key features of Apache Maven are dependency management, build lifecycle management, and of course, the convention over configuration principle and its plugin architecture. Then we have the Gradle, another popular build tool that is now used in many projects, particularly related to Java and Android development communities. It is an open source tool that was developed by Gradle Incorporation and is designed to be flexible, powerful, and easy to use. Gradle uses a domain specific language, the DSL, based on the Groovy programming language to describe the project structure, dependencies, and build process. It supports multiple languages and platforms including Java, Kotlin, Groovy, and Android. Gradle allows you to write your build script that are more concise and readable than Maven's XML based scripts. It also supports incremental builds, which can speed up the build process. Gradle supports a build cache, which can help reduce build times by reusing outputs from previous builds. It is widely used in Java and Android development and can also be used for building and deploying other types of software projects. It is interesting to note Gradle and Maven have fundamentally different views on how to build a project. Gradle is based on a graph of task dependencies where the task do the work. Maven uses a model of fixed linear phases to which you can attach goals, the things that do the work. Despite this, migrations can be surprisingly easy because Gradle follows many of the same conventions as Maven, and dependency management works in a similar way. Next, we have Buildr, a build automation tool that uses a Ruby based DSL for describing the build scripts. Builder is similar to Gradle in that it aims to provide a more concise and readable syntax for build scripts. It is primarily used in Java community, supports a wide range of plugins and extension for common build tasks such as compiling Java code, running tests, and creating executable Java files. So some of the key features of Builder are dependency management. It provides a powerful mechanism for managing project dependencies, including support for Maven and Ivy repository. Builder follows a convention over configuration approach too, in which developers follow standard project layout and naming conventions to simplify project configuration. It includes built-in support for running unit test and integration test, as well as generating code coverage reports. Builder integrates with popular continuous integration servers like Jenkins and Travis CI to automate the build and testing process. Next, we have Bazel, a build tool developed by Google that focuses on building large, complex software projects. It uses a language agnostic build description format and supports distributed caching to speed up the builds. Bazel uses a domain specific language based on the Starluck programming language to describe the project structure, dependencies, and build process. It has built in support for many popular programming languages and frameworks, including Java, C, Python, and TensorFlow. Build systems most similar to Bazel, very much like Bazel, are Pants and Buck too. Pants development and feature set were informed by the big tech organization, including those at Twitter, Foursquare, Square, Medium, and others. And Bug is a build system developed and used by the Facebook. It encourages the creation of a small, reusable modules consisting of code and resources and supports a variety of languages on many platforms. Bug is designed for building multiple deliverables from a single repository rather than across multiple repositories. So these are just a few of the popular build tools available for Java. Each tool has its own strengths and weaknesses. So the best choice for your project will depend on your specific requirements and preferences.